Have you ever contemplated India's remarkable advancements in space research? It's a journey of ingenuity and determination, underscored by numerous triumphs. At the heart of these feats is the Indian Space Research Organization, or ISRO, a beacon of scientific prowess and innovation. Their tireless endeavors have been instrumental in positioning India as a formidable player in the global space arena. One of ISRO's most recent milestones is preparing to launch its first X-ray polarimeter satellite, known as XPOSat. This mission is not just a first for India, but it also marks a significant addition to space-based X-ray astronomy on a global scale. The XPOSat will be placed in a low Earth orbit, carrying two scientific payloads, enabling simultaneous studies of varying features of bright X-ray sources. This satellite will be launched by the Polar Satellite Launch Vehicle, or PSLV, from the Satish Dhawan Space Center in Sriharikota, a testament to India's self-reliance in space technology. India's stride in space exploration is indeed noteworthy, isn't it? But what exactly is an X-ray polarimeter satellite, you may wonder? Well, let's delve into this fascinating concept. An X-ray polarimeter satellite, or XPOSat for short, is a spacecraft designed to investigate the polarization of intense X-ray sources. But why is this important? To answer that, we need to first understand what we mean by polarization. In the context of light or electromagnetic waves, polarization refers to the direction in which these waves oscillate. When light is emitted from a source, it vibrates in multiple directions. But when it's polarized, it vibrates in just one direction. X-rays from cosmic sources like neutron stars or black holes are naturally polarized. By studying this polarization, scientists can gain valuable insights into these celestial bodies' properties, like their magnetic fields, temperature, and geometry. Now, let's bring back our XPOSat. This satellite is equipped with a unique instrument called POLIX that measures these polarimetry parameters in the medium X-ray energy range. This information helps astronomers understand the universe in ways that are not possible with traditional X-ray telescopes. Also, XPOSat carries a secondary payload, SPECT, which provides spectroscopic information. Spectroscopy is a technique used to study the interaction between matter and electromagnetic radiation. In simpler terms, it helps us understand what celestial objects are made of and their physical conditions. So, why is the XPOSat important? It's simple. The XPOSat is a significant leap for space-based X-ray astronomy. It will allow for simultaneous studies of temporal, spectral, and polarization features of bright X-ray sources. This kind of multifaceted study is crucial in expanding our knowledge about the universe and its mysterious inhabitants. Moreover, the mission objectives of XPOSat include measuring X-ray polarization in the energy band of 8 to 30 keV and conducting long-term spectral and temporal studies of cosmic X-ray sources. These objectives are set to fill gaps in our current understanding of the cosmos, enabling us to delve deeper into the mysteries of the universe. Now that we know what an X-ray polarimeter satellite is, we can appreciate its significance in space research. Let's continue to explore and learn more about the universe, because every discovery, every observation brings us one step closer to understanding our place in this vast cosmos. So what's the story behind India's first X-ray polarimeter satellite, the XPOSat, and its mission? Well, the XPOSat, or X-ray polarimeter satellite, is more than just a fancy name. It's a mission that aims to delve into the mysteries of the cosmos, studying the polarization of intense X-ray sources. This mission is a significant milestone in India's space-based X-ray astronomy. Picture this: the XPOSat spacecraft, perched on the Polar Satellite Launch Vehicle, or PSLV, ready to be launched from the Satish Dhawan Space Center in Sriharikota. Its destination? A low Earth orbit. Its purpose? To carry two scientific payloads, allowing for simultaneous studies of temporal, spectral, and polarization features of bright X-ray sources. Now, let's talk about the mission objectives, which are as intriguing as they are ambitious. The XPOSat's primary goal is to measure X-ray polarization in the energy band of 8 to 30 keV. In layman's terms, it's going to take a good, hard look at the way X-ray light waves move, This information can tell us a lot about the sources of these X-rays, which include some of the most fascinating and mysterious objects in the universe, like black holes and neutron stars. But that's not all. The XPOSAT will also conduct long-term spectral and temporal studies of these cosmic X-ray sources. This means it will observe how these sources change over time and analyze the different wavelengths or colors of the X-rays they emit. The XPOSAT carries two payloads. The primary one, POLIX, will measure polarimetry parameters in the medium X-ray energy range. The secondary payload, XSPECT, will provide spectroscopic information, helping us to understand more about the nature and behavior of these celestial X-ray sources. The XPOSAT mission is a giant leap for India in space research, and we look forward to the exciting discoveries it will uncover.